Welcome to Energy Talks, a regular podcast series with expert discussions on power system testing topics. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. Welcome to our new Energy Talks miniseries called Cybersecurity in the Power Grid, in which we provide you with a 360-degree view of how power grids can best safeguard their infrastructures from cyber attacks. In our first episode in this mini-series, OMICRON cybersecurity expert Benjamin Teudeloff talks about the increasing pressure being placed on power providers to improve their cybersecurity practices. He gives insight into the evolving global landscape, the unique challenges faced by electrical utilities, and the importance of bridging the gap between information technology and operational technology, or IT and OT. Lastly, Benjamin describes how OMICRON's comprehensive products and services are empowering power providers to safeguard their infrastructure in an ever-changing threat landscape. Hello, Benjamin. Welcome to Energy Talks.
Thanks, Scott, for the invitation. I'm glad to be here.
Thank you again for joining me. Benjamin, could you tell us about your background in cybersecurity and also in the power industry?
Sure. I currently support OMICRON as sales manager for cybersecurity products and services. And previously, I worked as a police officer for the German Federal Police for over 12 years. Therefore, 9 years as a team leader in the field of IT forensics. Afterwards, I worked for almost 6 years in cybersecurity consulting for PwC and Ernst & Young. And my focus was on the development and implementation of ISMS according to ISO 20071 and BSI IT Grundschutz, the establishment and further development of risk management systems, the creation of security concepts, carrying out maturity analysis, and as well as audit preparation, audit support, and audit defense.
So which clients have you worked with in this area?
This varied greatly. I've worked with small state authorities up to various police authorities and a federal state parliament, medium-sized companies as well as large corporations. The most interesting thing for me were the different approaches to cybersecurity. These can differ a lot depending on the industry. The transport and logistics sectors or the manufacturing industry have a different focus than, for example, a data center operator or the energy sector. And critical infrastructures were a special case because of their importance for society.
Benjamin, what are the key developments in global markets that are exerting pressure on power providers to prioritize cybersecurity in their operations?
Political developments and global networking make the interdependencies and vulnerability of the energy utility system obvious. Global active hacker groups, some of them highly professional, represent a real threat to energy utilities. It is not easy to counteract this systematically or efficiently, especially when you consider that the grand general trend is towards digital substations, to name just one example. An example, the integration of IT technology with OT assets will continue to make progress. For many companies, this holds economic advantages and increases in efficiency, but it also means more attack vectors for cyber attacks. The formerly consistent separation of OT systems from the internet will no longer exist in this form. Many Asian energy utilities have already taken up this challenge, especially in the conceptual design of plants according to the international standard ESC 61850. IT and OT security is explicitly taken into account. I can absolutely support this approach as it has several advantages. On the one hand, we have the security by design approach, which focuses on system, product, and service quality. And on the other hand, security processes are thought of in a holistic way. In concrete words, company-wide information security risk management, security incident handling, periodic penetration tests, business continuity managements, and emergency strategies, both from IT and OT perspective. We are still talking about two fundamentally different approaches in the two areas. While IT security focuses primarily on risk management, In the sense of information security, OT focuses on security of supply. If my email server goes down for 48 hours, it's not nice, but the effects are manageable. If a power plant goes down for 48 hours, on the other hand, the effects can be quite different.
Definitely.
Apart from the financial and reputational damage in such a case, the joint coordination of the energy utilities is needed to compensate and maintain the security of supply. Otherwise, many companies and households could be left without electricity. The example also shows the different ways of working. While the IT security teams often consider the risks within the framework of their company, energy utilities have to think beyond their own company due to the system. Once again, back to the question of the cybersecurity approach. Regardless of whether an energy provider works with existing plants or has already considered the security by design aspects for new plants, the risks may remain high. The reason for this is often the long lifetime of components from existing plants, which can be a good 30 years or longer. At the time, cyber attacks or worldwide hacker groups were not considered because of the separation from the internet. The industry therefore has the challenge of securing seemingly old but well-functioning components and systems against current threats. For operators and security experts, this means above all knowing the technical weak points of the systems, minimizing them as far as possible, or securing them on the network side, so that the risk is manageable and the security of the supply can still be guaranteed. This balancing act is extremely difficult, and we must not forget, if an attack does occur, it is primarily the engineers who restore the security of the supply as quickly as possible. The IT department cannot guarantee that. Both areas, IT security and OT security, must work together even more closely in the future.
In the European market, how do power providers approach cybersecurity differently when compared with the rest of the world? Are there any notable trends or approaches specific to this region?
Within Europe, we have a strong interconnection of energy providers, which guarantee a constantly high level of supply security. The German transmission grid does not exist in isolated form, but is also connected to the grids of our neighboring countries. We are talking about the so-called International Grid Control Corporation, or IGCC. The energy transformation is an enormous challenge for the entire European sector. Renewable energies such as hydropower, solar power, wind energy, geothermal energy, and renewable raw materials will make an even greater contribution to electricity generation in the near future. The demands on the industry are therefore very diverse. For example, expand national and cross-border transmission capacities, and an infrastructure for hydrogen core network must be built and expand based on existing gas networks by the transmission system operators. In addition, battery storage solutions, prosumers, or photovoltaic systems will feed many new and regionally very different amounts of energy into the electricity grid. This can have a significant impact on the security of supply. On the one hand, through a higher need for control, keyword redispatch, on the part of the distribution grid operators, and on the other hand, through new technologies that must be securely integrated into an existing and functioning energy ecosystem. In parallel to the structural tasks, the energy sector still has to deal with many new regulatory tasks. One example is the Cyber Resilience Act, which focuses on safeguarding resilience, or the EU NIS2 requirements, which focus on cybersecurity. Within Germany, management liability is even being discussed as part of the national implementation of the EU NIS2 directive. The exciting thing from my point of view is that a power supply represents a complete system and must be considered as such. But this is exactly where we encounter the area of friction between the IT and OT. In other words, information security risk management at the company level and supply security in the entire electricity grid. The power grid can only be effectively protected and securely operated if all parties involved guarantee a minimum level of security standards.
Mm-hmm.
This starts with secure products, such as battery storage units, metering devices, and so on, and extends to the feed-in to the electricity grid and the rapid distribution of electricity loads and voltage peaks. For this, appropriate security and preventive measures must be taken on the part of the energy provider. This could be protection against cyber attacks through firewalls or system for attack detection, or through the establishment of business continuity management systems and restart plans or recovery plans in the event of an emergency. We can currently observe three trends in the European market. Firstly, there is often a lack of necessary management awareness for the topic of cybersecurity. This means that business success is not yet put in relation to the necessary security of the same. Mm-hmm. The security teams are often entrusted with the technical and procedural implementation of regulatory requirements and are sometimes left alone. Secondly, the interaction between IT security and OT security teams seldom works well. If possible, everyone tries to continue working independently in their own unit. Often, the requirements of the engineers, technicians, and protection control technicians are not considered sufficiently when securing products are put out to tender. This leads to frustration and, much worse, to poorly coordinated security processes and additional risks. Thirdly, due to the lack of management awareness, budgets for security systems such as firewalls, attack detection systems, or cybersecurity consulting services are still very limited. This often leads to a one-fits-it-all solution being sought in tenders. In the energy sector, however, we have two completely different network structures. The fast-moving IT world and the long-lived OT world with different systems, installations, and network protocols. In Germany, there's a saying, if you buy cheap, you buy twice.
That's interesting.
This is exactly what we are currently seeing with our customers. Supposedly, effective security systems have been purchased, but this cannot sufficiently cover the security requirements of the OT networks. This sometimes leads to security alerts not being taken seriously and sometimes ignored because too many false positive messages are reported by the SIEM, or the SOC security analysts have to spend too much time investigating the messages. Instead of minimizing risk, this increases them.
Benjamin, from your perspective, what are some of the key recommendations or best practices you would suggest to power providers seeking to improve their cybersecurity readiness and resilience, and of course, bridge the gap between IT and OT?
I would like to recommend that a company's management to pay more attention to the topic of cybersecurity. This is not about in-depth technical knowledge, but rather about the preventive and reactive value of their investments in the event of a disruption or a cyber attack. In concrete terms, how much is my company currently investing in cybersecurity measures and systems in relation to the potential damage? The CIO can provide very good support in this evaluation. I would also recommend the CIO and the IT security teams to pay more attention to the technical security requirements of the OT security teams or engineers and technicians. These are the experts for the systems and the OT network in your company. For example, organize periodic Jurfix meetings to exchange information. Only good internal cooperation helps to establish and optimize security processes. Due to the increasing interconnection of IT and OT networks, I would like to recommend that OT colleagues deal more with the topic of IT security in general and to actively search for an exchange with your IT security teams. This way, you can develop a common understanding of security issues on the one hand, and on the other hand, address and ideally budget for your security requirements for OT systems and networks.
So, Benjamin, apart from cybersecurity products, What specific services does OMICRON, for example, offer to support power providers in strengthening their cybersecurity posture?
Thanks for the question. Our customers highly value our cybersecurity products and our performance portfolio. For the individual challenges of our customers in the technical, procedural, and personal implementation of their requirements, we also offer a wide range of services. In particular, we provide support in the areas of engineering, security assessment, asset inventory, workflow processes, analysis and optimization, vulnerability and threat management, incident response services, security concepts for OT network, OT forensics, audit services, and trainings, of course. OMICRON's approach has always been to convince our customers with a high level of quality in our products and services. Furthermore, we proactively share our expertise with our customers. We have taken a consistent, holistic approach to our consulting services. If required, we already provide support in the conceptual design of digital substations, for example, or we analyze and optimize work and security processes together with our customers. Our expert support team assists in the analysis and evaluation of security incidents and, in case of emergency, also with the forensic analysis of e.g. PCAP data. Our audit team prepares audit participants for different audit situations and relevant audit questions in customer-specific trainings and gives tips on how to behave in audits. We also want to support the cooperation between the IT teams and the OT teams and to strengthen the common understanding. For this purpose, we offer 2 trainings: IT knowledge for OT employees and OT knowledge for IT employees. And especially in our lab in Austria, we can present live hacking to a substation. This allows our customers to experience a cyber attack live and receive tips and recommendations from our experts.
Benjamin, this sounds like a really great opportunity for hands-on training. Can you share any success stories or examples where OMICRON's cybersecurity products and services have made a significant impact on power providers?
Sure. We receive very positive feedback from our customers on a simple and intuitive operation of our cybersecurity products. They're easy to use for technicians and engineers and provide all relevant information and reports to a CM or SOC. We also have very few false positives, which significantly reduces the workload for everyone involved. The performance of our products and experts was recently confirmed again. A customer implemented an IDS from various competitors and then carried out various penetration tests. Quoting the customer, OMICRON security team was the most accurate and fast responding team between 3 other vendors. I'm not allowed to give further details yet. These will be released shortly. Of course, we are happy about such feedback. It confirms our own quality standard and makes it clear that our cybersecurity products effectively protect our customers from cyber attacks.
Benjamin, looking towards the future, what do you foresee as the most critical challenges or emerging trends in cybersecurity for the power industry?
I may repeat myself, but a cooperation between IT and OT must be intensified. Especially with increasing personal requirements, the existing expertise of the specialists in a company must be brought together. Furthermore, technological innovations, especially through the energy transformation, contain more security risks per se. Especially when you think of the area of IoT devices, there is too little investment in product security. In the worst case, this can have an impact on the security of supply.
Interesting. So how can power provider engineers interested in both IT and cybersecurity stay informed about the latest developments and industry best practices in securing power grids?
We offer training for engineers and technicians on the topic of IT knowledge for OT employees, and equally for IT employees, training courses on the subject of OT knowledge. On top of that, our customers can register via our customer portal and automatically receive newsletters on topics and products that are of interest to them. And last but not least, We will soon publish our new cybersecurity website. There we will present our products and support services in the area of cybersecurity services in detail. And depending on the specific industry, we will show different challenges of our customers are facing and how they can solve them. So you can stay excited.
Benjamin, thank you for joining me for this first episode in our new Energy Talks miniseries about cybersecurity.
It was a pleasure. Thank you, Scott, for your time.
And thank you again for being here with us. And a big thank you to our audience for listening to this episode of Energy Talks. If you like what you hear and have not done so already, please be sure to subscribe to Energy Talks on your favorite podcast platform to never miss an episode. We always welcome your questions and feedback. Simply send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing and offers you the matching solution for your application. This includes products for cybersecurity and the power grid. For more information, be sure to visit our website at omicronenergy.com. There, be sure to look under Applications to find matching OMICRON solutions. Knowledge sharing is very important to OMICRON. On our website, you can also find the latest papers on various power system testing topics, upcoming seminars and events, as well as webinars and training courses. Please join us to listen to the next episode of Energy Talks. Goodbye for now, everyone.